All right, it's Monday. Here's our new packet. Let's do a little packet walkthrough. A couple of the skills in math we need to take a look at. So you're going to need your packet, you're going to need your journal to take a couple of notes, and of course a pencil to write with or a pen if you need to. So I'll wait a second until you get those things. Got them? Okay, good. So to this week's packet, to start off, we'll start with the math section again. But to get into what they want us to do in here, I need to jump back to last week's packet. I made mention of a skill on here that I would talk about again, so I want to take a look at this, and you don't necessarily have to find last week's packet to go over it with me right now. So I circled this last week, and it has this term in here, common denominator. It's one we haven't talked about yet, and it goes through this whole big section here, and I said don't sweat it too much, right? I said most of the problems on this packet you could have solved using the 3 tips I gave you last week. We'll come back to this one and we'll look at number 4 because the 3 tips won't help you out with number 4, but common denominator will. So first things first, before we can get way overboard, start talking about common denominators, let's take a couple notes. So I'm going to get my book out from last week. I'm going to crank this neck up just a little bit. I'm going to turn the page so I have a fresh sheet of paper. So before I can get into common denominators, I need to know about this term here. Equivalent fractions. Okay, equivalent fractions, don't be scared of it. It's something we've already done a little bit of even last week. Equivalent fractions just means like we have 1/2. Remember this from last week? There's my pizza cut into 2 pieces. Is the same thing as 2/4. Same pizza, same amount of pizza, different looking fraction. So 1/2 and 2/4 are equivalent. They mean the same amount of stuff. Okay? I'm going to take you on a little tour through math law and tell you how this works. All right, so bear with me. I'm going to go down here, and we know this one. Anything times 1 equals whatever it was to start with, right? Anything times 1 equals the same thing. So 2 times 1 equals 2. 2,114 times 1 equals 2,114. We know this. We've learned this one already, right? So accept that as math law rule number 1 here. Here's the other piece of math law we need to kind of accept. Any fraction with the same number on top and bottom equals 1. Okay, and I know we haven't really used denominator and numerator as top and bottom numbers for right now, but that'll come a little bit later. And we'll start using them when we talk about common denominators, but I want to make sure it's really clear because we don't have a whole bunch of time, right? The top and bottom numbers, if they're the same. So 3 out of 3 means I have a pizza. I cut it into 3 pieces. I eat 1, 2, 3 pieces. That equals the whole pizza. Okay? Or 20 over 20. I'm not going to draw a pizza with 20 slices in there, but that also equals 1 whole pizza. All right? So there's the other piece of math law that you have to accept if you want to talk about equivalent fractions. The first one is multiply anything by 1. It doesn't change. It stays the same. Okay? And then this one, any fraction with the same number on top and the bottom is 1 in essence. Okay? It is 1. It doesn't change how much stuff there is. It just changes the size of the pieces. Okay, now let's add those two together, those two rules together, and we'll talk about how we can change a fraction to be whatever we want it to be. Scoop my page. So if I want to add 2/5 and 3/10, I've got a problem. We, in this class, can obviously add 2/5 and 3/5, no problem. We've done this for about a month now, right? Or over a month. And in fact, in this week's packet, you'll see a whole page of this, and it's going to seem like a little vacation. It won't take you long at all. We know that the bottom number doesn't change. The top numbers just add straight across. 2 plus 3 equals 5. But that won't work for our first problem here. I can go 2 plus 3 equals 5 on top, but then do I make it 15? That doesn't seem right, because now I've got 2/5 and 3 out of 10 is all of a sudden 5 out of 15. That's not how it works. So here's what we have to do. I need to change. It would be so much easier if these bottom numbers were the same. That's where this idea of common denominator comes in. I'm going to flip the page so I have a little bit more room. So I'm looking at 2/5 plus 3/10. And I'm spreading it out a little bit this time because I'm going to use a little bit of paper for this. So now we need to talk about common denominator. Common meaning same. Denominator meaning bottom number. Our lives are way easier if the bottom numbers are the same. We can add and subtract, no problem. But these are not the same. So, to find a common denominator, or the bottom number that's the same, I have to think about 5 as in like multiples of 5. If I count by 5, and if I count by 10, is there a number that they will both meet at? In this case, 5 can turn into a 10 by counting no problem. The question you have to ask yourself is, what would I have to multiply 5 by to make him into a 10? 5 times what makes 10? If you said 2, fantastic. So that means I'd have to multiply 5 times 2 to turn him into a 10. But in the fraction world, remember, I have to do the same to the top. Now what I've done here, you can see, I'm multiplying it by 2 over 2. Remember, 2 over 2 is 1. It means 1 whole. And we talked about the law that says anything times 1 doesn't change. So therefore, I'm not really doing anything. I'm just kind of changing the size of the pieces. So if I multiplied 2/5 times 2 over 2, or times 2 is really what I'm worried about, is this bottom number, the 5 would turn into a 10, just like I wanted, right? And the top, 2 times 2 would be 4. So that means that 2/5 is the same thing as 4/10. These two numbers are equivalent fractions. They mean the same thing, they're just cut up slightly different. I could keep on going, right? I could multiply this by 2, right? Or I should be better off just to show you that it's 2 over 2. And this could be 8/20 would be an equivalent fraction of 2/5. I could multiply them both by 10, right? And I can get 20/50 if I want to. Those are all equivalent fractions. They mean the same thing. Just like when I had 1/2, it means the same thing as 2/4. Look what happened. It's kind of like I multiplied both by 2. 2 times 1 was 2. 2 times 2 was 4. And we can see that down here. It makes more sense when we can see it, but equivalent fractions. Okay, so now I've got myself an equivalent fraction of 2/5 with a 10 on the bottom, and it is 4/10. So now my problem is, I'll clean it up over here for you, it's 4/10 plus 3/10. Now that problem becomes real easy for us. 4 plus 3, 7, 10 plus, or tenths just stays the same. There we go. So common denominators. My R looks like a N there, common denominator. Okay, same bottom number. So just to show you a couple of examples here, let's say I had a 3/4, and let's say I had a number that's not quite as easy to get to, let's say 2/5. All right, so this might be a little trickier. Let's find out. If I counted by 4s, 4, 8, right? Would I ever land on a number? I would never get to 5. If I count by 4s, I would never land, so I can't just change this one and have him meet at 5 there. So I'm going to just, on the side, I'm going to put a list of what the 4s might be. So it would be 4, 8, 12, 16, 20, 24. I'll just do this far. I'll just go this far. I'll do 1, 2, 3, 4, 5, 6 of them. And then I'll try, this is for my 4s. And I'll try my list for 5s. If I counted by 5s, this will be easier, right? 5, 10, 15, 20, 25, 30. I can keep on going. So when I'm looking for common denominators, I'm looking for numbers that show up both in this row and in this row. So 4, no. 8, no. 12, no. 16, no. Ooh, 20. 24, doesn't matter. This would be what we call our LCD, least common denominator, right? But we're just looking for common denominator. So they can both meet at 20. So if I want to change these guys, I need to find what would I have to do to both of these numbers to have them turn into a 20, because then I could change the bottom. So to turn a 4 into a 20, I need to multiply it by 4 times what makes 20? 1, 2, 3, 4, 5. So the same to the top as the bottom. That's the rule. So 3 times 5, 15. 4 times 5, 20. So 3/4 is the same thing as 15/20. If this seems a little bit crazy, if it seems like we're going a little fast, you are right. This is a skill that I normally would pan out over a couple of days. So feel free to pause and go back and scratch your head and email me, and I can walk you through some stuff too. Let's get this guy to 20. We would have to multiply 5 by to have him be 20. Let's see, 1, 2, 3, 4. Okay, so 4 times 5 and 4 times 2. Okay, 2 times 4, 8. 4 times 5, 20. All right, so now we have 3/4 and 2/5. Turns into 15/20 and 8/20. So 15/20 is our 3/4 and 8/20. And in this worksheet, you're going to see they still want you to be doing some comparing. So obviously, in this case, 15/20 is bigger than 8/20. Okay? So back to last week's packet. We have 3/5 and 7/10. If we look just our 3 rules, bottom numbers are the same? No. Top numbers the same? No. Are either of them bigger than a half? Yes and yes. And they're both kind of close. So let's see if we can use our new trick to solve this one from last week, our common denominator trick. We actually are going to get pretty easy with this one because we know what number they can meet at, right? 5 and 10 can both meet at 10. So what do I have to do to this guy? Multiply him by what to turn him into a 10? Multiply him by 2. And I'll do the same thing to the top. So 3/5 is the same as 6. 5 times 2 is 10. 6/10. And to change the other one at all, he's just a 7/10. So 6/10 versus 7/10. Now we can see that, yes, the 7/10 is bigger, but boy, not by much, huh? Not by much in this case. Okay, so let's take a look at this week's packet and see how common denominators might help us out in that first page. So in this first box up here, they're going to go through exactly what I just told you. They're going to say eighths, fourths, and halves, and you're going to write these in order from greatest to least. So they said, step 1, identify a common denominator. Find a bottom number that they can all agree to meet at. And in this case, they have the multiples of 8 are 8, 16, 24. Multiples of 4 are 4, 8, 12, 16, and 2, 4, 6, 8, right? And they found out that 8 is the place they can all meet up. So he doesn't have to change at all. These guys just have to change. Then it says, use the common denominator to write equivalent fractions. So they say now what they mean is change those other two fractions up, these other two fractions, so they have an 8 at the bottom. Okay? So in this case, there's the 1/4 is being 4 times 2 is 8, so do the same thing to the top. 1 times 2 is 2. 2 times 4 makes 8, so do the same thing to the top. 1 times 4 is 4. So now you have 2 eighths and 4 eighths. So then it says compare the numerators. In other words, you're just now able to check the top numbers out. The 2 versus the 3 versus the 4. Because the bottom numbers are the same, then life is a lot easier to handle. Okay, so this whole box just reiterates what I just did in the workbook. Doesn't make it way easier down here because, of course, like most of these worksheets, they don't give you a ton of space to do all this work. Okay? And in this case, we're not lucky enough to have all of the numbers meeting at the big number. So 3 and 4 and 6 can't all meet at 6 because if I count by 4s, I'm going to go 4, 8, and it's not going to work. Can you think of a number that 3 and 4 and 6 could all meet at? I'll give you 4 seconds. You're right, 12. All right, because 3 times 4 is 12, 4 times 3 is 12, 6 times 2 is 12. All right, so if I wanted to find out, so I have to do 3 times 4. This is going to be times 4. This is going to be a times 3. This is going to be a times 2, right? So that means I'm going to have 12s in the bottom over here. And we're still going to compare them, right? So 4 times 3 was 12. 4 times 2 is 8. 3 times 4 makes 12. 3 times 1 is 3. And then 2 times 6 is 12. 2 times 1 is 2. Now you can see this problem gets real easy. It says order them, write the fraction with the greatest value. So who's the biggest here? Bottom numbers are the same. The bigger the top number, the bigger the fraction. 8/12. Now, using the first couple tricks, right? If the top numbers are the same, bottom, if anything bigger than a half, in this case, he's bigger than a half, but these ones aren't, so he's going to be the bigger one anyway, right? So you can do some of these with the same tricks, but if you're practicing your common denominator, then you want to work on that. Again, 10, 5, and 2. Looks like we know that 5 can meet at 10 and 2 can meet at 10. So all you have to do is change these two to find out what they are. Oh, this one looks trickier. 1/8, 5/12, 9/10. You can try to do all the common denominator stuff. It'll be a little trickier, or you can use kind of common sense and see which one of these is the biggest fraction of all of those with the same 3 tricks we taught last time. This one says write the fractions in order from greatest or least to greatest, so put them in smallest to biggest. And more the same. Use these fractions, order them from greatest to least, and here's a number line to do so, and here we go again. You're ordering them from greatest to least, and some story problems. So there's your common denominator equivalent fractions quick blaze through. And then what you're going to get is a page where you can kind of pick up your feet and relax. It's literally adding fractions together that have the same denominator, the same bottom number. 3/8 plus 2/8 equals 5/8. This is something we've done for a while. And yes, it is just that easy. And they're also going to throw in some subtraction, which, again, we don't have too much trouble with. They've got some pictures for us even to look at. But, come on, focus in. There we go. They have pictures to show us what's happening, taking away this. But in the end, it's really just gets down to 3/5 take away 2/5 equals 1/5. This one's kind of cool. I want to see how many people get this one right. I like the way this is written. I had to read it a couple times to make sure I knew what they were talking about. It says Kate ate 1/4 of her orange. Ben ate 2/4 of his banana. Did Kate and Ben eat 1/4 plus 2/4 equals 3/4 of their fruit? Explain. So that'll be interesting, I think, to see. Okay, now on to the next fairly heavy bit of math to do today. This one. Rename fractions and mixed numbers. So this term here, fractions greater than 1, I've told you guys before, we used to call them, up to a couple of years ago, we used to call that improper fraction. And an improper fraction is a number like this, where it's got a bigger number on top than the one on the bottom. It means it's more than one whole thing, because 6 out of 6 is one whole thing. 17 out of 6 is way bigger. Okay, so sometimes when you're working with fractions and mixed numbers, and a mixed number is a big number plus a fraction. A big number and a fraction. 2 and 5/6 is a mixed number. So oftentimes they'll have you convert them back and forth, and that's what this worksheet wants you to do. All right, so time to get the workbook out again, or our journal out again. And I'm going to write mixed number. And again, I hope you're using this video. You can pause it, and then maybe you just work on the common denominator on Monday or Tuesday. And then you come back on Wednesday and pick this up from here. It's not designed for you to do this whole math packet in one day and try all these different things. So I'm introducing these topics. You're going to see them in the packet, and then I have assigned IXL skills to kind of reinforce what's going on here. So a mixed number, let's say 2 and a half. Big number and the fraction there. So if I took this big 2 and I broke it down into fractions, right? It would be like if I had a 2 on top and a 2 down below. Remember, that means 1 plus a 2 on top and a 2 down below. That also means 1 plus this 1/2. So this right here equals 2. 1 plus 1 equals 2, and then here's that piece. So if I wanted to then add this all up, we know what to do if the numbers in the bottom are the same. We just add the top across. The bottom won't change. We go 2, 4, 5. 5 halves. So 2 and a half is the same thing as 5 halves. Now there's a quicker way to do this. I wanted to show you why we're doing it this way, but there's a way quicker way. And once you get this down, it will be easy. Are you ready? Here we go. 2 and a half. All you have to do is this. Multiply the bottom number and the big number. And then add the top number. 2 times 2 is 4, plus 1 is 5. Check it out. Bottom number times the big number, add the top number. Bottom number times the big number, add the top number. Let's see if that works in our packet. It says, write the mixed number as a fraction. All right, let's see if Mr. Kuhn's trick works out here. Bottom number times the big number plus the top number. 3 times 3 is 9, plus 2 more, 10, 11. Done. Done. Just that easy. Same thing. 5 times the 4 plus the 2. 8 times the 4 plus the 3. 6 times the 2 plus the 1. That's how you can take a mixed number and turn it into a fraction. They call it fraction larger than 1. You also might hear improper fraction. Okay? Now, of course, they're not done with you yet. They want you to do the opposite of that, which is turn one of these back into a mixed number. Okay? We would spend a day working on this in class and getting really good at it, and then introduce this the next day, but hey, we're in a different time now. So, back to the book. I'm going to use my same example, only I'm going to turn the page now. I had 5 halves down here. So I'll use my or let's call it fraction greater than 1. Fractions greater than 1, and we had 5 over 2. We had 5 halves. Okay? And they want me to change that back into the mixed number. And so we did a little bit of, last time we did multiply and then an add. We're going to do the opposite of that for this one. I'm going to do a little bit of a divide and minus. So I ask myself, how many times will the bottom number go into the top number? How many 2's can I fit into a 5? If I go 2, 4, 6, so 2. I can get 2 chunks of 2 out of there. So that's the big number, 2. If I divide 2 by 5, I get 2. And then if I did that, right, if I took 2 chunks of 2 out of there, I'm taking 4 out. If I had 4, 5, take away the 4, that leaves me with 1 left over. So I divide and minus. I'll show you in a couple other ones here. Let's say I had 13 fourths. So I ask myself, how many 4's can go into 13? Let's see. 4, 8, 12, 16. Oops, too much. So 3. So that gives me 3 big ones. And then 3 times 4 was 12, right? So if I took 12 away from 13, take away 12, it's going to leave me with 1. And the bottom number stays the same. It's going quick, isn't it? Divide, pull that chunk out, and see what's left. Let's check the worksheet. All right, 32 fifths. How many 5's can I pull out of that 32 without going over? Let's see, 5, 10, 15, 20, 25, 30, 35. 6, because 5 times 6 is 30, right? So I pull out 6, which then gives me a big 6. Make sure he's bigger. They don't really do a good job on this worksheet because their font is the same there, but a big 6. So 6 times 5 was 30. So if I took 30 away from that, I'd end up with 2 fifths left. And they'll show you in their example a straight up division problem. And if that makes it easier for you, go for it, right? They have 16 thirds, and they put the 16 on the inside, the 3 on the outside, and they divide, and they get 5. And this is their remainder, the R1. Well, the R1 just turns into the fraction left over, 1/3. So whichever way works better for you. If you can kind of in your head find out how many chunks you can pull out, great. If you want to just take this and turn it into a division problem, that's great too. 3 goes into 1 0 times. 3 goes into 19. You're just kind of back where you started, right? How many 3's in 19? I think I'm going to be at 6 because 3 times 6 is 18. And if I subtract, I'm going to have 1. And that 1 comes on up, and we call him R1, but now he's going to be 1/3 left over. So 6 big ones and 1/3. Whew. Like I said, there are 2 pretty big concepts in this packet. The common denominator and equivalent fractions, plus converting between mixed numbers and Improper fractions, I wouldn't do that to you in a normal class day or a class week probably, but you're getting it in this packet, so I say we'll go for it. Give it a shot, see what you can do. IXL is also going to have these skills up there for you to practice once you've got it. Last thing in this packet. I know this video is getting pretty long, but now I want to talk about the ELA pages real quick because we didn't last time. These ones, the next math page is just converting. There we go. In the ELA packet, we have again, read and answer some questions, although they don't give you lines for it this time. You're welcome to, it says on another piece of paper, separate sheet of paper it says on here, you can put that on the back side of these clean pages. There's our math game for the week. Here, I want to talk to you about this one real quick because it's talking about something we've barely touched on, and that is Latin roots. Okay, a root word you had last week in there. Latin roots are a lot of our legal terms and medical terms have Latin and Greek in them, but these are some of the words we use. We don't even know that these little chunks of words are in there. So in this case, aqua means, as we can probably imagine, water or having to do with water. So I've got a blue highlighter. I'm just going to go through as I read these and highlight all the water ones. Dictionary, edict, predict, aquarium. This one's tricky. I'll come back to this one. This one's indict. Doesn't sound like indict or doesn't look like indict, but it is. Verdict, predicate, contradict, dictated, aquamarine. There's my aqua. Aquifer, aquatic, jurisdiction, dedicate, non-aquatic. So aqua means water. Dict means to say. In general things, this one means to say something. So the best way to remember that is this word right here, predict, right? If I'm going to predict the score of a game, I'm going to predict the weather for tomorrow, I'm going to means before, I'm going to say it before it happens, predict. And this one, like I said, I'm going to show you, this one sounds like, oops. It sounds like it should be written like this, indict, but there's a C in there too. So indict versus indict, right? You wouldn't say it that way. It sounds like indict. So I won't go through this all the way through. You're welcome to use a dictionary. You're welcome to use your phones. You're welcome to use this computer you're looking at right now to find out the definitions of these words so you can fit them into these sentences. But just know, aqua having to do with water and dict having to do with to say. And the last one is a prefix page, but boy, it seems pretty easy, right? It's got the word immature, inefficient, insincere. But check it out. If I just cover up these two prefixes, im and in, I get mature, efficient, sincere, polite, perfect, right? Im and in, the prefix just is canceling out what the word is next. It just means not. Kind of like if your shoes are tied or they're untied. Tied stays the same. You just throw UN in front of it to take it off of there, right? So if someone is mature, if you put an M in front of it, that means they are not mature. If someone is efficient at their work, and you put an in front of it, then they are not efficient at their work. So this one shouldn't be too much trouble. All right, give this packet a shot this week. I know there's some difficult skills in there to work through. Give it your best shot. Email me if you're having too much problem, and I can get a hold of you, and we can kind of work out some of these difficulties. Thank you so much.